Yes, please. In the last class, we described if there is an unbalanced fault, how to find out the fault current, how to find out the fault voltages, and how to find out the current flows into the transmission line during the fault or after the fault. And in that process, we told, first of all, in case of a unbalanced fault, first of all, we see whether what type of fault it is, and we described in the last class single line to ground fault. And we told in either of the unbalanced fault, means either single line to ground fault or line to line fault or double line to ground fault, any type of fault, since it is unbalanced, we cannot solve it on per phase basis because each phase having the different fault currents. So that's why we convert the whole network into the positive sequence impedance, peak positive sequence network, negative sequence network, and zero sequence network. Means any unbalanced system is converted into the three balance network, and at the same time, the unbalanced voltage source is also considered as a sum of the three balance three balance sources, which are called the positive sequence, negative sequence, and zero sequence voltages. Means there are three sequence voltages and three sequence network. Now, in case of a single line to ground fault, we told that like this phase the fault happens in the phase A here. If the fault happens to the phase A of the kth bus, say this is the bus of the kth in a network. In a network, each three phases, say at the kth bus, the three phases, phase A, B, C are there, and the phase A is become short circuited. So VA at the kth bus, I am telling you, the VA is equal to ZF and IB and IC is equal to 0. And for that, we find out the currents, positive sequence current, negative sequence current, and zero sequence current. They all were equal, and these were equal to the VK0 divided by ZK0, then ZK1, ZKK0, ZKK1 plus ZKK2 plus 3ZF. You remember this equation? Where ZKK1 is the kth row, kth column element of zero sequence impedance of Z bus. Means Z bus का zero sequence impedance, zero sequence network का Z bus का kth row, kth column element. Then ZKK1 was the kth row, kth column element of Z bus of positive sequence network. Similarly, ZKK2 was the kth row, kth column element of Z bus of negative sequence network. Plus 3ZF. ZF was the impedance by which the fault has happened. This is the value of ZF. This was the formula for the single line to ground fault. Now we will take the line to line fault. We will consider then line to line fault. In case of line to line fault, say in the network is having n number of buses, but at bus number k, the line to line fault has taken place. Line to line means phase V and phase C, any of the two phase becomes short circuited. Say V and C becomes, this is double line to ground fault. So first of all, let us have such type of, this is line to line. Phase V and C become short circuited. So in this case, and as we told, we assume that before the fault, the load is not connected, so load current is 0. So no current is there before the fault, but as soon as the fault happens here, as soon as the fault happens, what will happen when the fault happens? The fault happens here. So at this point, this new equation, that this is the voltage of phase B, VB will be equal to BC plus ZFIB. ZFIB plus BC is equal to this VB. So this is the one equation, and IA 0, and IB, since IB is this and IC is from here, so IB is equal to minus IC. These three equations take place at the kth bus, not all the buses. At the kth bus, these condition happens. Okay, is this clear or not? This is a line to line fault. Is this point clear or not? कुछ इसमें पूछना तो नहीं है बीरेश? इसमें कुछ पूछना तो नहीं है?
Okay, sir.
Now with this condition, now and at the before in case of an unbalanced system, in case of an unsymmetrical unbalanced system, yesterday we also described that kth bus VK, these three equations are very much important. This positive sequence voltages of all the buses, bus number 1, 2, 3, 4, and these are the positive sequence currents of at all the buses. This is the positive Z bus of the positive sequence. This is the pre-fault voltages of the balanced system, not unbalanced. It is a pre-fault voltages because before the fault the system was balanced. So this equation, in short, this is. So this equation, you remember, this will be needed again and again. Similarly, for negative sequence, there is no voltage source, otherwise the equation is same. Similarly, for zero sequence, this is the impedance. Here it is 0, 0, 0. There is a relation of positive sequence, negative sequence, and zero sequence voltage and current with their Z buses. So now we were describing this line-to-line fault, and these were the conditions. At kth bus, IA was equal to 0, and IB is equal to minus IC, and ZB is equal to BC plus ZFIB. This we have just now seen. So since we have seen this, and now we will convert. What we will do? We will convert these equations where the equations are in case of in terms of the balanced, unbalanced. We will change these. We will convert these into the sequence currents. So here IB, you see here, this IB and IC, these are the unbalanced current, and now we will convert it into the sequence currents, and this is a relation we know how to relate the current IA, if it is positive sequence, negative sequence current with this equation. Here this is the 1/3 and this is the A inverse. So in this way, this equation we know. Here also, so from here if you see IK 0, because we will convert this positive unbalanced system into the three sequence systems, three sequence currents, and these sequence current and sequence voltage we will put it here. Then we will find the fault current. So from here IK 0, you see, multiply this row with this column, since it is a plus IB and here it is minus IB and this is 0. So this row, when you multiply by this column, it will be 0. It means IK 0 is 0. Means there is no zero sequence current in line to line fault. And IK1 is equal to, if you multiply this row with this column, it is IB is common, it is alpha minus alpha square. Alpha minus alpha square IB. And in case of IK2, here if you see IK2, it is alpha square minus alpha. Here it was alpha minus alpha square, it is alpha square minus alpha. Okay, so the same IK1 is equal to IK2 with minus sign. So these are the means. This condition IB was equal to minus IC and IA 0. These equation, these are the unbalanced system equation, these has been converted into the balanced system equation, sequence current in this way. These are the sequence currents, IK0, IK1, IK2. And we know what is the value of IK1 and IK2. Okay, this we know. And this happens at the kth bus. Now, at the same kth bus, now we will talk about the voltage. This is about the currents. Now we will talk about the voltages. So, these are the relation between the unbalanced system VA, VB, VC into the three sequence voltages. From here, VA, VB, VC, we put it here. VV and VC will put here. So from here you can say what is VV? VV is equal to this 1 plus alpha 1 VA1 alpha square VA1 alpha VA2 for the kth bus. It is happens at the kth bus only, and VC is equal to from here. So this equation VV and VC for voltage and current equation we can write in this form. You see this VV is equal to 1 plus alpha square VA1 and alpha VK2. This. Similarly, VC. So we can write this value VV and VC, these two equation, and these two equation when you put it, the first equation, this VA, VV, if you put here, this VV, VC and ZF, IB. And IB ki kya? What is IB? IB is equal to from here. Means from here we will remove the unbalanced quantities that are the VV, VC, or everything here, VV, VC and IB will convert into sequence voltage and current. So VV, VC we have seen, and IB from here we will write IB is equal to, this IB is equal to 3 times of IK1 divided by alpha minus alpha square. So all these three will be, you will put into this equation 4.40. Then finally you will get, this is a VC is equal to VB plus ZF, VB is equal to VC plus ZF, and 3 ZF into IF. So this was the that. So IB, we have put it as a IB. This is the equation now. Now we will solve it. Here see VK0 and VK0 on both the sides is cancelled. Here it is a VK1, here it is also VK2. Alpha square minus alpha VK1, here also, here it is alpha minus alpha square VK2. So this equation can be solved in this way, like alpha square minus here, alpha square minus alpha. And this already was there. So from here you can find this IK1, because our intention is to find the positive sequence, negative sequence, zero sequence currents. If we find positive, negative, zero sequence current, then we can find the unbalanced voltage, unbalanced current IB and IC. Then we can also find unbalanced voltage BB and BC at kth bus and all other buses also. So from here we can write the equation for this IK, alpha minus alpha square. If you multiply here, this, after taking this common alpha square minus alpha, from here also if you take alpha minus square alpha, so this will be the here, because minus if you take inside, so VK2 minus VK1, VK2 minus VK1, alpha minus alpha square common, this alpha minus alpha square is there also, this in the numerator, denominator, it will also go into the here numerator. If you multiply this will be alpha raised to the power 4. This and this will be alpha raised to the power 4, and these two alpha raised to the power q and alpha square. Alpha and alpha is alpha square. And we know what is alpha raised to the power 4. Alpha is equal to alpha q is equal to 1, because alpha is equal to 120 degree. So alpha q is equal to 1. Here if you write 1, so it will be alpha only. So it is alpha. This is alpha square, and alpha q is equal to 1. It is minus 2. So and if you add plus 3 and minus add 3. So it will be 1 plus alpha square minus 3, and 1 plus alpha square we have seen earlier, it is equal to 0. So this, the whole value of this from here to here, it is a minus 3. From here to it is minus 3. This can be written as a minus 3 VK2 minus VK1. Hello? Okay, minus if you take inside it will be the, and 3 will be cancelled, VK1 minus VK2. Now these are the positive sequence. This is the positive sequence currents. These are the positive sequence voltage. It is negative sequence voltage. If we can write this positive sequence voltage and negative sequence voltage from the earlier equations which we have described, that from the network of complete network that I just remind from here. This was the complete network from here for all the buses. From here, for the kth bus, we can write VK1 here. VK1 from here, if you write the VK0, ZK1, these all currents are 0. So all this ZKK IK1 means VK0 minus ZKK IK1. Here equation, and from here VK2 is equal to ZKK2 IK2. Similarly, from here VK0 will be equal to ZKK0 and IK0. Rest currents are 0 because fault happens only at the. So this complete network, all voltages described earlier, and if you put these values here, this we calculated. We have calculated this. ये किया था calculate. यहाँ हम VK1 and VK2. We put the value of VK1 and VK2. VK1 was this. Just we have shown it is a VK1. It is a VK2. If you put here VK1 minus VK2 here, and we know we have just seen VK2 is equal to minus VK1, so minus minus plus. So this can be, you can put it here VK1 and VK2. So VK1 minus VK2 will equal to this here equation, and this is the ZF. So IK1 is equal to divided by ZF. Now you see this IK1 here and IK1 here, both bring on this side and divided by ZK1, ZK2, this equation will come. Means IK1, positive sequence current in case of a line to line fault is VK0 divided by ZKK1, ZKK2, ZF. उसमें क्या था? सिंगल लाइन टू ग्राउंड फॉल्ट में क्या था? सिंगल लाइन टू ग्राउंड फॉल्ट में क्या था? VK0 ZKK2 plus ZKK3 plus 3ZF. सॉरी, ZKK1, ZKK2, ZK0 plus 3ZF. यहाँ देखिए एक तो ZK0 नहीं रहा, जीरो सीक्वेंस करंट नहीं है, और यहाँ 3ZF की जगह ओनली ZF है. And otherwise positive sequence current was equal to the negative sequence current in the single line to ground fault. Here positive sequence current is the minus of the negative sequence current. So you should remember, and should remember the difference between the two also. दोनों के बीच में difference क्या है वो भी आप ध्यान रखेंगे. And here zero sequence current is 0. Once, so ये तीनों current आ गया. Once you find for the kth bus, if you find positive sequence current, negative sequence current, and zero sequence current, if you find, then what will be the net current? If you, यहाँ से पता लग गया, what is this VK0? Who will tell? इसको कौन बताएगा? निखिल बताओ, what is this VK0? निखिल, धीरज, रीनू, चेतना, ब्रजेश.
Zero sequence of the volt.
Pardon?
Zero sequence network of voltage of zero sequence.
नहीं. VK0.
VK
VK0 is the kth voltage of the kth bus.
Yes sir.
Before fault. जीरो सीक्वेंस की बात नहीं है, जब फॉल्ट ही नहीं था तब. बैलेंस के केस में, बैलेंस सिस्टम जब था उस समय जो वोल्टेज था वो है VK0. तो एंड इट इज नॉर्मली 1 as I told at no load we consider system is at no load before the fault, so VK0 is normally 1. Otherwise from the load flow study we can calculate the value of VK0. Okay, so we know IK1, IK2 and IK0. Okay, once we know IK1, IK2 and IK0, then we can find the here you see, from here we can find, if we know IK1, IK2, then we can find IB. Okay, यहाँ से IB निकल जाएगा. इस kth बस पे एक्चुअल बैलेंस अनबैलेंस करंट कितना है from here. So IB, if we know this, so we can find IB, and IB is equal to minus IC. This is already 0. इसका मतलब क्या हुआ, हमें अनबैलेंस सिस्टम का A फेज का, B फेज का, C फेज का तीनों अनबैलेंस करंट पता लग गया. Now once we find the current of the unbalanced system and all the sequence currents, then next object becomes what are the post fault voltages of all the buses. Post fault voltages of all the buses. Then reverse again, we will apply this equation from this. These are very important. I told in the beginning, from here, since all the current, only that kth bus current is there, from here we find for the first bus, second bus, third bus, for all the buses we can find, all here are zero, only this is there. So we can find the voltages of all the buses, positive sequence voltages of all the buses, 1 2 3 4, positive sequence voltages, negative sequence voltage of all the buses with this equation. Similarly, zero sequence voltages of all the buses. So once we know voltages of any bus, then for the same bus we can find the voltages also, actual voltages. We know zero sequence, positive sequence and negative sequence voltages of any bus. So we know the voltage is unbalanced voltage of phase A, phase B, phase C of that bus. So in this way, we calculate the unbalanced voltages of each phase also for each bus. Okay, so this is about the line to line fault. Now you can take this double line to ground fault. In case of, इसमें कुछ पूछना तो नहीं है
सर? अगर जो हम मतलब जो V की हमने 0 लिया था, वो V2 0 और V3 पे जहाँ पे फॉल्ट होने से पहले हमेशा 1 रहेगा ना?
कौन सा V के 0 करें आप?
यस सर।
V के 0 एग्जैक्ट अगर निकालना है तो लोड फ्लो स्टडी से निकालते हैं, लेकिन नॉर्मल वे में वी कैन कंसीडर V के 0 इक्वल टू 1 बिकॉज एज्यूम्पशन लिया है। एज्यूम्पशन क्या लिया? बिफोर द फॉल्ट सिस्टम इज एट नो लोड। फॉल्ट से पहले सिस्टम पे कोई लोड नहीं है। और क्यों ऐसा लिया है? क्योंकि जो लोड करंट होगा वो एक्चुअल में जो फॉल्ट करंट है उससे काफी, लोड करंट अगर 1 पर यूनिट है तो फॉल्ट करंट 10 और 15 पर यूनिट होगा, 15 टाइम्स होगा। तो उस 15 टाइम्स के कंपैरिजन में हमने लोड करंट को नेग्लिजिबल मान लिया, इसलिए वोल्टेज हमारा जो सिस्टम वोल्टेज था वही हमारा बसेस पे वोल्टेज मिल गया। अदरवाइज फॉर एक्चुअल एनालिसिस वी विल डू द लोड फ्लो स्टडी एंड विल फाइंड द वोल्टेज ऑफ एट ऑल द बसेस, और वो हम V के 0 लेंगे। अच्छा, ये तो बात हो गई हमारा वोल्टेजेस का। एंड सपोज हमने लोड फ्लो स्टडी से एक्चुअल वोल्टेज लिया। नाउ जो एज्यूम किया था कि लोड करंट इज 0, बट इन फैक्ट लोड करंट इज नॉट 0। लोड करंट इज आल्सो ऑब्टेन्ड फ्रॉम द गॉस सीडल मेथड। गॉस सीडल मेथड करते हैं तो हमें हर एक बस का PQV डेल्टा आ जाता है। उस PQV डेल्टा, V और डेल्टा पता है तो लाइन फ्लोज का मतलब हर एक बस में, हर एक लाइन में कितनी करंट फ्लो हो रही है वो निकाल लेते हैं। तो जो फॉल्ट करंट यहाँ निकल रहा है, फॉल्ट करंट जो निकल कर आया, अगर हमने जो विद अजम्पशंस सिस्टम वाज एट नो लोड, तो उस समय जो फॉल्ट करंट निकला उसमें एक्चुअल जो करंट था, लोड करंट, जो एक्चुअल करंट ऑलरेडी फ्लो हो रहा था उसके साथ उसको सुपरपोजिशन थ्योरम अप्लाई करेंगे। मींस जो फॉल्ट करंट आया और पहले उस लाइन में जितना भी लोड करंट था उसका एल्जेब्राइक सम इज द नेट फॉल्ट करंट। वो उसका फॉल्ट करंट जो निकला था उससे थोड़ा प्लस और माइनस भी हो सकता है, बिकॉज एल्जेब्राइक सम मींस उसमें जो करंट एक्चुअल करंट था वो ऐड हो जाएगी या सब्ट्रैक्ट हो जाएगी डिपेंडिंग अपॉन द डायरेक्शन ऑफ करंट। तो वो ये हो गया हमारा लाइन टू लाइन फॉल्ट। नाउ डबल लाइन टू ग्राउंड फॉल्ट। लाइन टू लाइन मींस V और C, देखिए B और C कनेक्ट हो गए। पहले क्या था, B और C कनेक्ट हो गए थे लेकिन आपस में कनेक्ट हो गए थे, ये नहीं था ZF। अभी एडिशनल आ गया लाइन टू लाइन फॉल्ट के साथ में ये ZF आ गया, मींस ग्राउंड। लाइन टू लाइन कनेक्ट होने के बाद में ग्राउंड हुए हैं विद इम्पीडेंस ZF, दैट्स व्हाई इट इज कॉल्ड डबल लाइन टू ग्राउंड फॉल्ट। तो इस केस में भी देखिए एज वी नॉर्मली एज्यूम एट नो लोड, सिस्टम इज एट नो लोड बिफोर द फॉल्ट, सो IA इज 0 और इवन IB और IC भी 0 था। फॉल्ट जब नहीं था तो IB और IC भी 0 था, लेकिन फॉल्ट हो गया तो IA तो ऑलरेडी 0 है तो रहेगा ही, क्योंकि यहाँ तो फॉल्ट हुआ ही नहीं है। लेकिन इसमें दिस कैन नॉट बी 0, यहाँ तो फॉल्ट हो गया IB और IC। तो यह इक्वेशन जब ये दोनों आपस में टच हो गए तो इसका दोनों का वोल्टेज सेम हो जाएगा। तो VB इज इक्वल टू VC VB is equal to VC, and from here if you write the equation, this VB IB plus IP, you see this में kth बस पे जो IB plus IC into ZF is equal to VB, और this is equal to same will be equal to VC. तो अब ये तीन कंडीशन हो गई हमारी, IA 0 है, ये वोल्टेजेस है, ये करंट्स है. तो हम एक तो वोल्टेजेस, ये जो हमारे वोल्टेजेस हैं, अनबैलेंस वोल्टेज ऑफ फेज बी एंड फेज सी, ये हमने अनबैलेंस वोल्टेजेस, हमने इसके सीक्वेंस वोल्टेजेस निकालेंगे. सबसे पहले क्या करेंगे, इसके सीक्वेंस, पॉजिटिव सीक्वेंस, नेगेटिव सीक्वेंस वोल्टेजेस इस कंडीशन से निकालेंगे वोल्टेजेस, और ये करंट्स IB और IC इन टर्म्स ऑफ करंट, इन टर्म्स ऑफ पॉजिटिव एंड नेगेटिव सीक्वेंस, और उसकी वैल्यू यहां रखेंगे. Then after putting all these things, we will convert, means we have converted this unbalanced system into the three sequence, into the sequence voltages, positive, negative, zero sequence voltages and sequence currents. After, if you do and put in that equation, then as we proceed into line to line fault, we will proceed into the double line to ground fault. Here, then we will get the positive sequence current, we will get the zero sequence current formula, and we will get the formula for the this is the negative sequence. तो तीन करंट्स निकलेगा, जैसे हमने इसमें निकाला था लाइन टू लाइन में, वैसे यहाँ निकालेंगे. आई लीव इट फॉर यू. ये सिंगल लाइन, डबल लाइन टू ग्राउंड फॉल्ट में जिस तरह यहाँ प्रोसेस किया है, same process you will follow. You can take the help of any book and you elaborate this. ये तीनों जो हमारा इक्वेशंस आया है, इसको आप ड्राइव करेंगे, तीनों इक्वेशन. इट इज नॉट डिफिकल्ट. सिमिलर, ऑन सिमिलर लाइन वी विल यूज, यहाँ ये चीज भी यूज होगा, जैसे हमने हर एक में ये यूज किया है. तो यू टेक द हेल्प ऑफ एनी बुक, यू विल फाइंड these three equations: positive sequence, negative sequence, and this about the zero sequence. Once we find three sequence currents, we can convert with the help of the conversion, we can find the unbalanced current in case of double line to ground fault. As we proceed earlier, we will find the voltages of all the buses, positive sequence, negative sequence, zero sequence voltages of all the buses after putting this, and then we find the voltage of all the buses, unbalanced voltage of all the buses. So I hope you can do it. इसको आप करेंगे, ये थोड़ा सा आपके लिए हमने छोड़ा हुआ है, एंड दिस वी विल कंसीडर एज असाइनमेंट. ये आपको केवल इसको ड्राइव करना है इक्वेशन. नाउ देखिए, इस पे हमने न्यूमेरिकल क्वेश्चन ऑलरेडी, yesterday we have given the numerical question, we explained the two numerical questions for the unbalanced fault, whether it was single line to ground fault, line to line. There is no difference between, only the equations are different. Any network, if the fault occurs, unbalanced fault occurs, you have to convert that network into the three sequence network depending upon the directions, depending upon the connection of the transformer. So positive sequence network, zero sequence network, and negative sequence network, तीन नेटवर्क कन्वर्ट ड्रॉ करेंगे. उन नेटवर्क के तीन जेड बसेस बनाएंगे, और उस पे इक्वेशंस डिपेंडिंग अपॉन किस टाइप का फॉल्ट है, आप उसे इक्वेशंस लिखेंगे और आपकी करंट्स आ जाएंगी. तो ये इक्वेशंस करंट का आ गया. फिर आप वोल्टेजेस का इक्वेशन लिखेंगे, जो ऑलरेडी आपको बताया हुआ है. सो आई होप न्यूमेरिकल, आफ्टर going through the numerical question, two numerical question yesterday I have given, you will be able to understand everything about this. At the same time, we have given a computer program also to write the computer program in the experiment as experiment number 10. तो जब आप कंप्यूटर प्रोग्राम लिख लेंगे एक्सपेरिमेंट नंबर 10 का, उसके रिजल्ट को मैनुअली जो आपने किया है उससे जब कंपेयर कर लेंगे, आई होप यू विल हैव द फुल कॉन्फिडेंस ऑफ सॉल्विंग एनी टाइप ऑफ फॉल्ट, any type of numerical question for any type of fault. And at the same time, by putting the data only, you can do it, you can find it, find the same result through the computer program. So, is there any question in this? If you have any question so far, you please ask. Because unit number 2 is complete now. Unit number 2 is complete. Now we will take the rest of the 2 units. One unit is on the state estimation. Another unit is on one is the state estimation and another is on the contingency analysis, that the security analysis. So there are 2 units. Those 2 units we will take in the